Yeah, hi, good evening, everyone. I hope everyone is doing well. So, guys, welcome to our 30 days free short term training program from Python to AI, right? So, we'll quickly understand where we are, okay, and what will be the next topics, what will be the next modules that we are going to learn in the next coming few days. Then we'll start for the day, right? So, successfully, we have completed Python module is done. Okay, so as part of Python, we have understood all the basics, all the foundations that are required to build or to work on any ML or AI project, right? So in order to work on any ML, machine learning or intelligence project, we have to learn Python, and whatever we have discussed as part of the Python module sessions, those are enough for time being. Then comes the second module, where we are going to learn EDA, exploratory data analysis. What exactly is this exploratory data analysis? We are going to start this module from today. Okay, so what kind of analysis we have to perform on a raw data, what insights or how insights should be grabbed from the raw data, everything will be understanding from today, right? Then next to EDA, we have data cleansing, where we understand how to clean the raw data. So the raw data might have some kind of duplicates, some extreme values called as outliers, some missing values, and sometimes data might not be normal. So everything will be such kind of activities will be performed in this phase. Okay, so that will be next module. And next to data cleansing techniques, we'll understand ML primer. And with respect to primer, we are also going to understand the differences between supervised algorithms, unsupervised algorithms, then k-means and KNN algorithms. Okay, very widely used algorithms in machine learning, k-means and KNN. We'll discuss these two with use cases. After completing ML algorithms with use cases, nothing but projects, we'll discuss the important topic, that is neural networks. Under neural networks, we have ANN, CNN, and RNN. So these three will be discussing along with the use cases. So this will be the next plan for the next coming few days. But today we are going to start EDA, exploratory data analysis. Okay, so what is this EDA and what is the methodology that we are going to learn as part of any project that we are going to do? We are going to understand today. So, guys, focus. Majority of the time today, it will be like a theory class, but this theory will help you to understand the upcoming concepts. If you don't, you know, focus, just ignoring a theory class, you may not. Involve well under these concepts in the next coming few concepts, right? So successfully we completed Python module. Great. So all these topics were being discussed. Whatever we have promised that we'll be discussing, all the topics were being discussed, right? So introduction to Python was done, features were being understood. Then software installation, I'm supposed to post a video for this separately. Then variables, operators, data types, then conditional statements, loops, functions, NumPy and Pandas module. All these topics were being covered, right? If you have any kind of questions, or if you have any kind of, if you are facing some errors, use the comment section. Okay, so under all the videos you'll have a comment section, right? Whatever might be the question, even if it is even a silly question also, you can ask me. That's fine. Okay, so post the question in the comment. We'll reply hardly in a few minutes. Right? So Python module done. The next module, EDA, Exploratory Data Analysis. Okay, so people who are working in the same domain might be in, say, machine learning or artificial intelligence, might be working as, data analyst, data scientist, or even data engineer might be aware of EDA, because this term is generally, these things are generally done by data analyst or data scientist. So they are actually habituated of using this word EDA. But what is EDA for a person who is coming from different domain? Okay, so I'll start from scratch and we are going to understand EDA from beginning till the end. Okay, so what exactly is EDA? We'll understand this. Right. But in order to do any kind of project, it might be machine learning project or deep learning project, whatever it might be, you know, we have to follow a methodology, right? There should be some cycle, or there should be some process, so that everyone gets, used of it. So in our case, that project management methodology is called as CRISP MLQ. Initially, we'll understand what is this CRISP MLQ. Okay, what exactly is this CRISP MLQ? We'll understand. What are the different phases that we have in CRISP MLQ? Also, we'll understand. Post understanding CRISP MLQ and the phases of CRISP MLQ, we'll understand the characteristics of data. This is important, because if you don't understand the data, what are the characteristics? If you don't understand the characteristics of the data, you cannot proceed further. You cannot do any kind of next operation on the data, right? So understanding the characteristics will be done. Then data collection, how the data is collected in real world with respect to the project, what are the different types of collection steps we have, we'll understand under data collection. And next to that, we have first moment business decision, second moment business decision, third moment business decision, fourth moment business decision, and finally data visualization. Okay, and finally data visualization. So all of these together called as EDA. Okay, so what is this first moment, second moment, third moment, fourth moment, and what are the different ways we can visualize the data? Okay, so all of these we are going to learn under EDA. Together, EDA is nothing but exploratory data analysis. We are going to explore the data and perform some kind of analysis. So the raw data that was given to us by the client, okay, in the projects, right? The data that was shared to us by the client, you have to perform some kind of analysis on it. Okay, so that you'll understand what exactly the data characteristics are. Right? When you understand the data characteristics, you'll understand the data distribution. Right? So when you understand the data distribution, you can finally go and visualize the data. Okay, visualization is nothing but pictorially representing the data. Okay, so when you visualize the data, you'll get some insights. These insights play a crucial role. Okay, these insights will help will help us because we are going to share these insights to the client. Okay, so based on these insights, client will take some actions. In general, for visualizing the data in real world, many of the companies, many of the organizations, they use any one of the business intelligence tool. Okay, out of the widely used BI tools, the very most widely used tool is Power BI. Power BI, and even if you are aware of Tableau, this is also a BI tool, business intelligence tool. Okay, so Power BI, Tableau, what is the purpose of learning these two tools is we can visualize the data, but are we going to use Power BI in this space? No, we visualize the data using Python only. Within Python, we have modules which help us to visualize the data. So this is different and this is different. Our next program will be on Power BI Tableau. We'll ignore it for now. So data visualization, don't assume that we are going to use any kind of BI tool. Within Python, there are n number of modules which help us to visualize the data. So using those modules, we'll also understand how to visualize the data, right? So everything we'll be discussing in detail. Pay attention and focus, guys, right? Yep. So let's get started for the day. And as I have discussed earlier, if you have any kind of issues, okay, if you have any kind of technical questions, please use comment section. Okay, I'll will reply you for all the questions within a minute. Right? Yes, modules like Matplotlib, C1, Plotly, okay, they are used for data visualization. Yep, good. We'll talk about these modules in the coming few days. Okay, probably tomorrow or day after tomorrow. Right. Let us understand what is this CRISP MLQ. Okay, so CRISP MLQ is nothing but it's a project management methodology. Project management methodology for any project, okay, especially a machine learning project or a deep learning project, nothing but AI project. Okay, we have to stick to one kind of methodology, right? So that methodology that we are going to use is CRISP MLQ. What does this CRISP MLQ stand for? It stands for cross industry standard process for machine learning with quality assurance. I repeat, CRISP MLQ stands for Cross Industry Standard Process for Machine Learning with Quality Assurance. Okay, so it's a standard process which is used universally for machine learning projects. Okay, and with quality. Quality is something they expect in real world days. So this methodology is very widely used in real world. CRISP MLQ, right? Yes, it's an acronym. So CRISP is the abbreviation stands for Cross Industry Standard Process for Machine Learning with Quality Assurance. So this is the abbreviation for CRISP MLQ. And previously, I mean, a few years before, CRISP MLQ is termed as CRISP DM. CRISP again represents the same cross industry standard process for data mining. Okay, at that time in CRISP DM there is no quality assurance, but okay, in the new methodology which got updated, they have added quality assurance. Okay, so what are the phases of crisp MLQ? We'll discuss one by one. Crisp MLQ contains in total 6 phases, whereas crisp DM contains only 5 phases, guys. Okay, what is the fifth phase that was added? We'll discuss. Right. Crisp MLQ in total contains, it has 6 phases. First phase is business and data understanding. So, what do you infer or what do you understand by this phase? Business and data understanding. It's nothing but understanding business problem. Okay, business problem, which is nothing but the problem that the client is facing. Okay, so I have written it as BP. Don't assume BP as something else. BP means business problem. Okay, I know men will be men, so don't assume BP as something else. It is business problem, guys. Okay, then business and data understanding. Initially, whatever the problem, the business problem that client is actually facing, we are supposed to understand the business problem, then followed by data understanding. Understand the data. Akhil, what can we understand from the data? That's what I'll tell you. This is very important phase. If you don't understand the business problem and the data that was shared by the client, what you are going to do in the next phases? Nothing, right? So, understanding the problem that was given by the client and the data that was shared to us plays a crucial role. It affects the next phases. If you are not, if the communication between us and the client is not done properly, okay, that effect will be on the next phases. So, what exactly are we going to do in this phase? We are going to look today. We'll understand this particular phase one. Today, this is very small phase but important phase. This is very small. Why? Because are we going to sit and understand, do it for years? No, because understanding the problem probably takes few days than the data followed by the data. So we'll do a lot of research in this space. I should keep it as like this. A lot of research will be done as part of phase one of crisp MLQ. What do you mean by research? What do you mean by research again? Research means you'll go and look out for any other projects that were done similar to this use case. You will have one use case, right? So, based on this use case, your business problem, you will go and look out for many, research papers. You'll search for any kind of project was done similar to this project. Okay, if there is already an existing solution, you'll try to replicate the same. If there is no existing solution, you will come up with a new solution. That's what we do. That's why it is termed as data scientist. What does a scientist do? Scientist does research. Yes, obviously. If we are hired as scientist in real world, okay, for ISRO or NASA, what does a scientist do? They'll do a lot of research, right? So in the same way, a data scientist will perform research on data. Okay, even if you are hired as a data scientist in future, you will do a lot of research. You'll look out for any kind of possibility. Okay, by mapping your case with previous similar projects that were done, right? Then comes data preparation. What is this data preparation? Are we going to prepare any kind of data? No, no, friend. Then what are we going to do in this phase, Akhil? In this phase, we will do three major things. One is EDA, Exploratory Data Analysis, performing analysis on the raw data and extracting the insights will be done as part of data preparation only. So EDA is part of phase 2 of CRISP MLQ. Okay. Is CRISP? Yes. In if you take any machine learning project, and if that particular organization uses CRISP MLQ methodology, for sure they'll use only the 6 phases. Okay. So yes, for each and every use case of, for each and every business problem, for each and every machine learning project, it might be an AI project also, CRISP MLQ will be used, right? So that is the reason I'm taking time to explain all these phases, because you people coming from different domains, this is something should be, I should push more this into your brains so that you'll stick to this methodology in future as well, right? So next to business and data understanding, we have data preparation. As part of data preparation, the first sub phase in data preparation is EDA, exploratory data analysis, where we do lot of analysis on the raw data. Why am I using the word raw? Because the data that was shared by the client, for the first time we are going to use it, it's pure raw, right? In the pure raw format, the data will be there, and we'll do analysis on the data and we'll get insights from it. Okay, these insights we'll share to the client, right? Then next to EDA, we have cleaning or cleansing. We'll also perform data cleansing activities. As we discussed, the raw data might have duplicates, the raw data might have outliers, the raw data might have missing values. So all these kind of techniques will be performed as part of cleansing. And then feature engineering. Features are nothing but columns. Okay, on the columns we'll do some kind of engineering. So this is nothing but checking the relevance. Okay, we'll do feature selection, feature extraction. Okay, so feature selection, feature extraction will be done as part of feature engineering. We'll discuss guys when this particular phase comes. Then the third phase, model building. Model building is nothing but, we build a model. What do you mean by a model? What is the meaning of a model? First of all, model means, you mean role model? No. Model means, in general terms, I'll keep it C. It's nothing but it's a mathematical equation. It's a mathematical equation used to predict your output. Why machine learning, AI, deep learning algorithms are getting more fame nowadays? Because they are actually doing predictions. Am I right or not? Yes. The Y that you see here is representing output. Y is output. Okay. Then what about X, Akhil? X is nothing but inputs. Okay. Then what is F? F is a function. So I take a function. My goal is, by taking all the inputs, I have to make a function of inputs. So using these function of inputs, I can predict my output. Uh, Sorry, Akhil, I'm unable to actually, understand properly. Can you just give me an example? Yep, sure. predicting or prediction of temperature, or let me keep like this: tomorrow's temperature. Can we do that using, crisp MLQ? Yes. Is it possible? Yes. Yes, it is possible, my friends. How do you get, or when you open Google in your mobiles, okay, how Google is actually giving you the weather predictions? Can someone tell me? In the back end, they use a time series algorithm. A model has to be built based on the data, and this model is actually predicting your temperature for the next hour, for the next day. See, okay, so what is the technology that is being used? Machine learning. Machine learning is a widely used technology nowadays, but is it a new technology? No, it is not a new technology. It's not a new concept that was invented over a decade, or say, or early 2000s. It was there from 1950s only. But the thing is, during this time, there is no that much data available. Okay, and that is the reason all these, output have gone wrong. But nowadays, you take any organization, you take any place, there is data captured. If there is data captured, and this data can be used for, you know predictions. By taking this data, I'll build a model, whatever might be there. Depending on the use case, we can predict the output. See, yes, today, I don't know how many of you have watched the test match between India versus Australia. Okay, so border Gavaskar trophy is going on, right? So today, the last day, day 5 of test 3 between India and Australia, and due to the rain, it was declared as draw between India and Australia. Am I right? Yes. So, can we predict even a match? Yes. We have worked for an, very leading client within India, where they run a popular gaming site. Okay, so we have come up with a model, and this model will predict which team will win, which team, nothing but which country is going to win. Sorry, for the last World Cup, ICC World Cup 2023, we have, you know did this as a project. Is that possible? Yes. If you have data, anything is possible. Get the right data for, cleansing, select the right features by using, then come up with the right algorithm to build the model. So the model will actually predict with an accuracy, and maintaining its accuracy, the output will be as is. Okay, so model building is nothing but building an equation like this. This is termed as model. Y is equals to f of x is termed as model. Okay, so let us not go more into this model building phase. We'll talk about all these phases in the coming few days. Okay, I'll just give the overview of rest of the 3 phases. Then we'll start with the first phase. Next to model building phase, we have evaluation. Evaluation. What do you mean by evaluation? The general meaning. Evaluation is nothing but you are evaluating. Nothing but you are, gauging the performance. What you are evaluating? You are evaluating your model's performance. Is your model performing well or not? If it is performing well, and if it is reaching, or if it is meeting the client's expectations, then okay. If it is not meeting the client's expectation, we'll tune the model. Okay, so might be these words are completely new, but I want you guys to cooperate. Okay, so model's performance will be evaluated. Good. Post evaluating the model, if it is meeting the requirement, we will deploy it. What do you mean by deployment? Deployment is nothing but moving your model into the production. Okay, so into the client's environment, we will deploy the model. Whatever the model that we have, build it, whatever the model that we have evaluated in our environment, that will be deployed to the client's environment. Okay, yep, launching in simple ways, yes, launching, yep. And finally, the important phase, monitoring and maintenance. This is important because this is the actual phase which is missing in CRISP DM. Data mining methodology, whatever we have discussed earlier, in this CRISP DM, there is no monitoring and maintenance. But in CRISP MLQ, this phase was added. What exactly is monitoring and maintenance? Monitoring means you are continuously monitoring your model's performance at client's environment, how it is performing. Is it performing good on the new data? Because client will generate or client gets new data on daily basis, right? So for this new data, how the model is performing? Is it performing well or is it not performing? We will monitor continuously. Okay, if it is performing well, we need not tune the model, right? But if it is not performing well, we do some kind of maintenance. See, if you have a knowledge of just English or English language, you can easily remember all these phases, guys. What exactly this phase means, you can understand, you can memorize for a long time. Understanding business and data in phase one. And in phase two, you are preparing your data for phase three. Okay, in order to do model, in order to build a model, you have to prepare the data first of all. That doesn't mean you have to create the data. Data will be shared by the client. So this data, raw data might have, some unwanted things. We have to do some kind of cleansing activity on those unwanted things. Then selecting the right features. Might be each and every column present in the data might not be useful for the model. As part of this equation, might be some columns are not required. So feature selection should be done. Feature extraction should be done. So this will be done as part of feature engineering. Once the data is prepared, go for building a model. Once the model is built, evaluate its performance. If the performance is good, then deploy it. If the performance is not good, tune it. Okay, once if it is deployed, monitor the performance of the model at the client's environment. Okay, if there is no kind of issue, if there is no drift, proceed. But if there is a change with respect to the accuracy that was promised to the client, okay, then we'll do some kind of maintenance, like how we do maintenance for our vehicles. In a similar way, we'll do maintenance for our model. I hope it's clear. Okay, so this is the actual, uh, clear introduction for CRISP MLQ with respect to each and every phase. And now let us proceed with, you know, the next slide, that is, yep, the architecture. Understanding, 1 minute. Understanding the business and the data. Okay, so it's like a cycle, guys. Okay, so understanding the business and data, followed by data preparation, followed by model building, evaluation, deployment, monitoring, and maintenance. If you have some kind of maintenance that should be done, you'll directly come to this phase. From this phase to this phase, you'll come, and again you'll tune it, again you'll evaluate it, again you'll deploy it, then perform monitoring and maintenance. So a complete cycle, right? Now, now comes actually the business and data understanding, the first phase of CRISP MLQ. What exactly is business and data understanding mean? Business understanding means understanding the business problem thoroughly, where we have to you know prepare a document. A document has to be prepared. Okay, so that document is called as project charter. A project charter has to be prepared by our team between, so that whatever the client told us or whatever the client has informed us regarding the business problem, what is our objective of doing this problem, what are the constraints, what are the goals, okay, what are the timelines, what is a budget. In this way, everything can be documented. Everything should be documented in the project charter. Okay, this is a document, and this holds the complete high level information of the project. It will have the high level information about all these things regarding a project. Actually, is it mandatory? Because I'm not that much good at documentations. That's okay. Even if you are not good at documentation, let your teammate do it, because as part of a project, there will be 10 to 15 people working on it, right? So one of the mate has to prepare this, or together as a team you have to prepare a project charter. Why it is that much essential? What is the main reason for it? Simple ways. The main reason of building a project charter is, creating a project charter is, are you sure that client will stick to his words or will stick to her words? They'll tell X, they'll ask us to do X, okay, and later after some time we'll do X, but they'll tell, why did you do X? I have asked you to do Y. So who is responsible for this? Are we responsible or client responsible? So in order to maintain whatever was discussed verbally, a document has to be prepared, and that document contains all the high level information, the discussion between us and the client, tracking all the important information, including timelines, milestones, budget. Okay, so every when should we on weekend basis or on daily basis they'll be connecting with us. So everything, each and every input that was shared to us by the client will be documented in this charter, right? And this at the end of the day should be signed by our project manager and the client. Okay, if it was not signed, that means they did not agree to this high level information. So at the end of the day, our project manager and the client, both of them will sign this project charter. Then from then, the actual project starts. Till that point, we will not start even a single point of work. Will not work. So project charter is very essential, the first document that we will be preparing. Now let us talk about objectives and constraints. Objectives are nothing but your goals. What is your goal? You have to define it clearly. What are your constraints? Define them. Constraints are nothing but limitations. In order to achieve our goals, there will be some limitations, right? So those limitations are nothing but constraints. Define the constraints properly and keep it in the project chart. Define the scope of the project. Okay. Define the risk. Everything. Each and every point has to be documented as part of this chapter. Okay. Once if it is created, make sure that client has agreed with the high level information and signed it, and then we can start with the project. Good. Now comes the next piece, data understanding. Before proceeding to the next phase, in first phase itself, you have to understand the data. What do you mean by understanding the data again? Understanding data is nothing but understanding its characteristics. Check whether the data is structured or semi-structured or unstructured. Or identify whether your data is cross-sectional or time series or panel data. Okay. Or check whether your data that was shared is big data or non-big data. Nowadays, this word you might have heard for multiple times, right? Big data. Big data. Okay. So we'll discuss what are these, we'll discuss. And finally, check whether the data is balanced or imbalanced. Oh my God. So should I check all of these? Yes. If you don't understand the data characteristics in the first hand itself, you can't proceed to the second phase of Prism MLQ. Okay, so structured, semi-structured, unstructured. What is structured, semi-structured, unstructured data? What do you mean by structured, semi-structured, unstructured? Right. Structured, the name itself, it's giving a hint for us. Structured, the data which is organized, okay, which is organized into rows and columns. The data which is present in the format of rows and columns, which is kept organized, structured, okay, plus by default it will have schema. That means if I keep serial number, so that means only one, the serial number has to be part of column 1. Then name, only name should be part of column 2. In the same way, structured means it is organized, and by default it will have data definition. What do you mean by data definition? Data definition is nothing but the schema. You will define what kind of data should be part of each and every column. Whereas semi-structured, it is not fully structured, it is semi-structured, which means data will be in the form of rows and columns, but no schema. The data will not have any kind of data definition. Okay, even if you change it, it is accepted. Then the third one is unstructured data. So it is completely not structured. It is unstructured. So data which cannot be, kept in the format of rows and columns in its raw state. That is unstructured data. Actually, it's better if you give an example for all these three types. Yes. So this is actually representing structured data is the data which the widely used examples are databases, guys. You take any relational database management system, okay? It might be Oracle database, Maria database, Postgres, MySQL, MS SQL Server. You take any database, Data will be in structured format only. Semi-structured, widely used examples are JSON files. It is semi-structured. And unstructured will be images. Can keep an image in rows and columns in its raw state? I'm asking it in raw state, not in the form of pixels. Okay, if pixels, yes, but I don't want pixels, right? I want the image as is, but in the form of table. Is it possible? No. So it is an unstructured data. Videos, audio, text, speech, all of these comes under part of unstructured data. Okay, so we will be dealing with either structured or unstructured data only. So either relational data, the data which is present in a database, or these unstructured data, which is nothing but images, videos, audio, speech, text, so on. Right. Now, let us go to the next topic. Cross-sectional versus time series versus panel data. What is the meaning of cross-sectional, time series, or panel data? Cross-sectional data is the data, first of all, these three are representing structured data only, guys. Under structured only, we have these three types. The data, which is in the format of rows and columns, which has multiple features are nothing but multiple columns. Okay, there are multiple columns, and the main point is the data will not be in the sequence. The data will not be arranged in any sequence. Okay, data will be like as is, and it will not be arranged in any sequence. But time series data is the data in which it will have only two columns. One is time variable, and the next one is your y output variable. Okay, so time variable is nothing but it gives or it holds data related to time. It might be date. Okay, it might be the date might be in the form of daily data, monthly data, yearly data, whatever it might be. Okay, then the output, in simple examples, I can take sales of dmart. This is a grocery shop, right? So a store, grocery store. So in order to capture the data of DMart, I'll just capture with respect to day wise, day sales. So by taking this data, can I predict or can I forecast the next tomorrow's sales? Yes. But this comes under time series. Time series data is the data in which there are only two columns, only two variables. One will be the time, the next one will be the output y, and the data will be in a sequence of time. But here in cross sectional, no. Data will not be arranged in any sequence. Why? There is no time column. If you have time column, then obviously data should be arranged in the sequence of time. Okay, that makes the difference between cross-sectional time series. Then what is panel data? Panel data is also called as longitudinal data. Okay, what is longitudinal data or panel data means? Panel data is nothing but combination of time series and cross-sectional. Oh my God, what does that mean? It means we will have n number of columns, multiple columns is accepted, but out of these n number of columns, one column will be time, and the data will be arranged in the sequence of time. So it holds the properties of both cross sectional and time series. Such kind of data is called panel data. Is it clear? Is it clear or not? Yeah. Now comes big data versus non-big data. So big data is nothing but, in simple ways, big data can be defined using four V's. Okay. So big data is nothing but data which is defined using four V's. What are these four V's? Four V's represent velocity, then volume, then variety, and finally veracity. I'll keep it over here. Velocity, which is representing the speed at which the data is being generated in the real world. Then volume. Volume represents the size, how big the data is. Then variety. What are the different types of data it is generating? Is it generating images? Is it generating video? Is it generating text? So different types of data, variety. And finally, veracity. Veracity is nothing but uncertainty in the data generation. Okay, so all these four V's together, no, it say about big data. A big data is defined using four V's: the speed at which the data is being generated, the size of the data, the different types of data it is generating, and finally the uncertainty in the data. Okay, so if a data holds all these four V's property, it is termed as big data. If not, it is termed as non-big data. But in real world, everyone started working on big data. Majority of the projects, okay, it might be banking sector, finance, even gaming sector, whatever it might be, everyone started using big data. But big data, in order to work on big data, the traditional tools that everyone should learn are Spark and Hadoop. Might be you guys have come across these. So start learning Spark, Hadoop. As we are aware of Python, it's better if you learn PySpark. PySpark is an API of Python and Spark. So almost all the commands, all the syntaxes will be same, the functions and all. So start learning Spark, guys. It will be very easy for you. And in future, we'll do a session on Spark as well. Right. And finally, balanced and imbalanced data. So data, before we continue to the next phase, in real time, we have to check whether the data is balanced or imbalanced. What do you mean by that, first of all? What do you mean by balanced, imbalanced? Are we going to weight? Are we going to check its weight? No. Doesn't mean balanced, imbalance is nothing but we are not going to check any weight of the data. It means, let me keep it here: x1, x2, x3, x4, y. I have a data. Okay, so in this data, there are four inputs and one output. Okay, so the output represents the actual, based on these inputs, this is the output, right? So we got some output, right? So in this output, we will have, classes. What do you mean by classes? Huh. Classes are nothing but the labels. Okay, so for example, I have, let me take your students, right? So let me take your, I'll take an example of your data only. Your name, x1 is nothing but your name column. Next to name column, I have your preparation time for exams. Okay, next to preparation time column, I have time that you are consuming on social media. Okay, how much time do you spend on social media? And finally, say your might be gender also. Yeah, this is something important. Gender, male or female. I'll take all these four inputs, and in y, the output, it's nothing but it will have your pass fail. Okay, it's a two class problem. There are only two classes. One is pass class and the second one is fail class. So I'll take all the data. I have a students of 100 people. There are 100 students, and I have recorded the data. If a student, if he or she preparing for more time and spending less time on social media, whatever might be the gender, for sure they'll pass. Am I right? Yes, they'll pass. What if the preparation time is less and consuming more time on social media? Might be, for sure they will fail, right? So in this way, I'll record all your data and I'll try to understand what is my, or how many classes do I have in my y variable. In my y column, I have two classes. One is pass and one is fail. Right? So, how many students have passed? Assume that 70 students, or let me give like this, 90 students passed, only 10 students failed. This is my data says. This is what my data says. Okay, so now check whether your data is balanced or imbalanced. Balanced or imbalanced, you have to decide it based on your y column, output column. Initially check how many classes do you have in your data. I'm working on a two class problem. Pass is one class, fail is one class. So now check the proportion. It's 90 is to 10. So nothing but it's 9 is to 1. Right? So what does balanced data tell is each and every class present in the y column, you know, it should hold at least 30% of the values. Each and every class of output column should have at least 30% of the values. Out of 100 students, what is 30% means? It means 30. So pass class should have at least 30. Yes, it's met. In the same way, fail class also should have at least 30 values. But is that condition met? No, it's not met here. So it is an imbalanced data. It is an imbalanced data. Right? So balanced data means in your output column of the data, check the classes initially. Each class should hold at least 30% of the values. Okay, Akhil, I have 50% and 50%. 50 pass, 50 fail. Under which category does it fall? Obviously balanced. 50-50, right? So each class is greater than 30 values? Yes. 70%, 30%? Yes. 80-20? No. Because if this is 80 and this is 20, here the condition is not met. So obviously it is imbalanced data. Right? So I hope you guys understood balanced and imbalanced, right? So, data characteristics should be understood upfront. If you don't understand the characteristics of the data, you cannot proceed to the next phase. Right. Again, if it is balanced, I'll proceed. Good. What if my data is imbalanced? Like in this case, what should I do? Should I proceed? No. You should not proceed with imbalanced data. If you take imbalanced data and do model building, or if you build a model on imbalanced data, your predictions will be wrong. Whatever the predictions that we will do in future, it will go wrong, right? So you are supposed to balance the data first, then only you have to go upfront. You have to go to the next piece, right? So what do you how do you make an imbalanced data balance? There we have multiple techniques like k-fold cross validation, SMOT, modified SMOT, undersampling, oversampling. In this way there are n number of techniques, and one of the techniques should be used to make your imbalanced data balanced. So we'll discuss all of them as we go on. So let us jump into the next topic. Okay, so data types. The next topic is data types. Akhil, I think we have discussed data types, right, in Python. Yes, those data types are different and these data types are different. Data types with respect to Python are, fundamental data types, str data type, then list category data types we have, set category data types we have, dict category. So all these are data types with respect to Python. But what are these data types? These data types are nothing but data types with respect to analytics, continuous and discrete. You should understand the data type of the data. Okay, so what is the meaning of discrete data and what is the meaning of continuous data? I have kept it in a small table. We'll understand, it doesn't take much time, right? So the definition itself says, you know, discrete data are nothing but the countable data. Okay, data which is separate, distinct values is nothing but discrete data. But when it comes to continuous data, the data which is measurable is continuous data. Okay, so any value within a range is nothing but continuous data. So if you take examples, you see here number of students. Can I keep it as, you know, if I ask number of students in a class, can I keep it as 100.02? Is it a right? Is it giving me any, is it making sense? No, right? I should keep it as either 100 or 101. Right? So, discrete data represents the countable data, and in general, it is nothing but whole numbers. It represents categories. Whereas when it comes to continuous data, it is actually representing the data which is in decimal format. Okay, example, height, weight, time, then the temperature. All these we can measure to any extent, right? So these are measurable. Such kind of data is continuous data. So this is a crisp introduction for discrete and continuous. And the next slide is with respect to data collection, guys. So primary and secondary data. Okay. So what is this primary and secondary data? Whatever the data that we will be working on should be collected, right? If it is not collected, how can we work on the project? First of all, we should have the data. If you don't have the data within the hand, you can't do any project. So this collection is actually classified into two types, primary and secondary. What is the meaning of primary data? The data that we collect at the source. Okay, so the data that we will be collecting at the source. Whereas secondary data talks about the data that is existing with us. The data that we have with us is nothing but secondary data. But the data that was collected at source is nothing but primary data. And the best examples are surveys. When you do a survey, or let me keep it straight. Last year we had elections, right? Sorry, this year, my bad. In 24 we have elections, right? So, as part of elections, some of us might have undergone some kind of survey. Who will be the next Prime Minister of India? Okay, they'll give you some four options. You are supposed to answer it. It's a part of survey. Does they have the data within themselves? No, they have collected at the source. Okay, they have approached many sites, many places of the country, and each team will visit different places and they'll conduct the surveys. Whatever the data that they'll be capturing, they will hold it and they'll do some kind of analysis. Whoever gets the majority of the votes, they'll declare that this person will be the next prime minister. Right, that's what happened. So surveys will be the best example for primary data, the data which is collected at source. Whereas for secondary data, databases will be the best example. Because the data that I have, I'll store it in my database. So the existing data I'm storing in my database. What will be the cost and time effect? For primary data, I have to spend more time and I have to invest more cost. It's not that much easy to get the original data, right? So it takes lot of time to collect primary data, and in the same way, it takes lot of I have to invest lot of cost. Whereas secondary data, as the data is with us, I need not spend anything. Okay, so low time and low cost, no investment, nothing. Even if you have some kind of investment, but it will be very less. When it comes to the variable of interest, nothing but the accuracy. Okay, accuracy is actually talking about the data that you are collecting. Is it reliable? Yes, highly reliable. Why? What is my variable of interest? I want to know who will be the next Prime Minister of India. For that, I am going to do survey. I'll invest time. I'll invest money. Everything. Am I getting the answer? Yes. You'll get the right data here. Whereas under secondary data, it depends on the source. You may or may not have the right variable of interest depending on the project might be. Okay, the data might be reliable or may not. Here we are not sure. Okay, and the examples. So primary data and secondary data are the two different types of data collection, and these are the differences. Right. So I think, yep. So we are done for the day. If you have any kind of questions, yes, it's time for your technical questions, guys. We'll continue with the next topic tomorrow, that is data preparation. And from tomorrow, it will be hands on. I'll take a use case and we'll do EDA and all these things, you know, for each and every use case. Right. Any questions? Yep, the link has been provided and you can proceed. If you have any kind of technical questions, you know, please feel free to ask. It was shared in the chat, my friend. Check. Yep. If you feel these sessions are really amazing, share across. Okay. Panel data is nothing but it's a combination of both longitudinal, cross-sectional data and time series data. So panel data contains multiple variables, but the data will be arranged in the sequence of time. Okay, so whatever the properties that we have defined for cross-sectional data and time series data, if you merge both the properties, those will be the properties of panel data. Clear, my friend? Yep. Feedback form was shared. You can give your valuable feedback. Don't miss out these form because this is actually marking your attendance, guys. Yep. If you feel these sessions are really amazing, yes, share across multiple channels, and these sessions are generally made for you people only, and share across multiple channels. Just before you leave, hit a like and please comment if you have any kind of questions. Thank you so much, guys. Have a great day. We'll connect tomorrow and continue with the next topics. Signing off.